Okay, Assalamualaikum. We will continue our discussion with the translation. Okay, my name is Ainur Hanani binti Rozmi and my matrix number is 205428.
My name is Hafiz Shafi'i bin Muhammad Puzi, number matric 205784.
My name is Alina Jo binti Abdul Muttalib. My matrix number is 205220.
My name is Ahmad Daniel Benzali and my matric number is 207138.
My name is Alia Farzana binti Muhammad Farouk and my matrix number is 208218.
Okay, we will start the translation exercise. Okay, the given verse is the transcript of a bacterial pal gene. The gene encodes for pal, an enzyme that catalyzes the conversion of PHE to cinnamic acid. Underlying nucleotides represent its RBP, which is the ribosomal binding protein, and start codon. Okay, give the amino acid sequence of the gene. If does anyone want to try?
I would like to try. So the amino acid sequence start from the underlying AUG until the stop codon UGA at the ending. So it's AUG, GAU, GGA, CAA, dot dot dash dash dot dot, AAC, GAU, AUG, GUC, and UGA.
Okay, but what is the answer for the amino acid sequence?
So the
My answer is methionine, aspartate, glycine, glutamine, asparagine, aspartate, methionine, valine, and stop codon.
okay,
I got the same answer with Ainul.
right, the same.
Answer like you.
Okay, does anyone got the different answer? No. Okay, no. Okay, so let's proceed. Predict whether the transcript can be translated efficiently. What do you guys think about
May
this?
I try?
Yes, you can.
Yes.
In my opinion, the transcript can be translated efficiently due to the presence of ribosome binding site, which increase the probability of the ribosome to attach to the strand. So therefore, the translation process can occur efficiently. So that's my answer.
Does anyone got the
What
different
about you
answer?
guys?
My answer is yes, because it has strongest ribosome binding site. It means the ribosome binding site is consensus. So the translation is stable because the consensus and the translation become efficient.
My answer is, can I try?
Yes, you can.
My answer is, the key factor for my answer is the same as Akmal. Because of the RBS factor.
Oh, my answer same as Alia Najwa.
I'm the same as Akmal due to RBS factor.
I think our answer is same because we explained about the ribosome binding site, right?
Yes, yes.
Okay.
Yes.
Continue with the next question. Okay. And number 3, predict what will happen to the level of PAL enzyme under the following conditions, which is the first is the deletion at position 8. What do you guys think?
Like, I think it remain unchanged.
Yes, I get the same answer.
Why is it remain unchanged?
Because it does not affect any of the transcription site, perhaps.
Oh.
I think it
Maybe
remains same.
Like,
I do not understand that this part. Can someone explain?
I think it remains same because when we delete A at position 8, the A at 7 will make AGG also. So that's why it remains same.
Yes.
I think it remains the same. First because it is still an AGG and AGG, the the pile enzyme, but because of the RBS factor, because of the RBS factor is still the same. So I think translation will still also occur.
Okay, thank you, thank you.
Okay, then we will proceed with the second, which is a deletion at position 11, which is at here, A. My answer is decrease.
Chris,
6 decrease.
Yes, decrease because there is no RBS anymore.
Yes.
Yeah.
Is there any different answer? No.
no. Same.
No.
Next, an insertion of U at position 32.
I think it is decreased because when we insert U at position 32, it will make a different code different amino acid.
Yes.
Yes,
For the same answer.
same
May
answer.
I add something?
Okay.
Yes.
Yes, my answer is the same as Sarah Naja. It will decrease and change the amino acid sequence. Also because the proline the group of amino acid is different. Proline is hydrophobic and it became serine, which is a hydrophilic.
Yes. I can accept that answer. Okay. There's no argue, right, about this? Okay, we will continue. A deletion at position 31.
Is it decrease?
Here. Yes.
Decrease because the exchange of the amino acid when we delete the position 31.
All right. Same answer.
Same answer.
Next, I will continue, okay? A deletion at position 35 and insertion at G of the position 30. My answer is the same.
I think it remain unchanged.
Yes.
It will remain unchanged.
Also remain unchanged.
I think it decreased.
Oh.
Why?
Because
Why?
it decreased because position what 25, right?
Right.
23.
It will decrease because the aspartate group is a negative charge, and then the glycine is hydrophobic. That is one. That is one factor, and then the other factor because it will produce how do I say it? It will produce okay. So what I change UC become the UC until GG become UC AUG AUG GG, right? If we delete the position 25 and at the 30, right?
Yeah.
And then it will have 2 AUG. If you write it back. At there. And then what I wrote back is UC, AUG, AUG, and GG. I wrote from the 21 until until the end. So there will be 2 start codon, but it's okay to have 2 start codon. But the start codon actually encodes for something else, which is methionine. So that is that is another changes in amino acid sequence. I think so because there is an addition of methionine. And then the
Yes, and-
arrangement is.
Okay.
Did you get what I'm saying?
Yes.
So I think it will decrease also.
Does anyone wants to argue with her statement?
I'm a bit lost. Can you repeat?
For me,
You start
um,
AUC ke AUG?
Oh,
start with
I start to take from UC, from the 21.
Yes.
Okay, so I did UC, AUG, GAU until GG at first.
okay.
Okay, so if we delete and insert the respective thing, it will become UC,
Mhm.
AUG, AUG, and then GG.
Okay.
Okay, so AUG there, AUG and AUG, both of them are start codon. It is okay to have start codon because we have the mutation, but the start codon could also code for something. Stop codon could also code for methionine. So there is difference. There is changes in the amino acid sequence, in my opinion, because of that. You guys get it? Or do you guys want me to?
I got it. But does everyone agree?
So I think it will decrease lah.
I think it remains same because when we delete G at the position 25, the codon for AUG is same because G at 26 uh, will be to the left, right? Will be take place G that we delete. So the AUG is still same, and when we insert G also at position 30, I think the sequence is not changed because AUG,
Yes.
GGA also.
Yes, the AUG,
Huh?
and AUG will stay the same, and then the GG will stay the same. But in between, in between, it will become GAU, and then it will translate into AUG. You get it? And then GAU is aspartate. It is a negative charge, and AUG is actually glycine, if I'm not mistaken. So it is hydrophobic. So it is not in the same group.
But
This
you start with the 21, right?
yes.
But can I know why you start with the 21 and not the AUG here to start codon?
Okay. Let's say if it starts from AUG, also it will have the mutation. Did you guys
Yes,
want me to asking my
but-
answer?
But if we start with this AUG, this one will shift here, right? So and it will be the same.
No. Okay, let's say the UC we delete. Okay, so AUG and then we delete the G.
Right.
The G will replace the AUG. It will become the start codon. Okay, get it?
Yes.
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 The next sequence, the next
Mhm.
sequence will
Yes.
be AUG.
Yes.
Yes.
Also a start codon.
Yes. Okay.
Also a start codon and also could code for methionine.
Okay.
Okay, so and then the belakang the N1 is still the same, right?
Mm.
No. The A. Oh my god. Okay, so can you
Okay.
please draw the 3333?
Okay.
Sorry.
Okay.
So it changed from GAU to AUG.
Okay, so AUG.
From
You put time. Thank you.
AUG here
AU.
and AUG here. Okay.
No. AUG and then GAU. That
GAU.
is
And here.
Okay.
Here.
and then GGA.
Okay.
Okay.
All right.
So the AUG and GGA will remain the same.
Okay.
But the G,
GGA will remain the same. Or it will become GGC, right? Because something like that. But then the GAU will change to AUG. So that is the difference between that is a different group of amino acid.
I think that makes sense.
yes, yes.
Can you understand? Oh, finally.
Yes, I understand it.
So, and then the GAU is aspartate. But when
From
it
Matthew.
become AUG, the AUG is not an aspartate. It is a glycine. And then it's also start codon. It's two start. That's why.
Okay, I understand now.
I agree. Okay, should we move to the next question?
Yep.
Okay. Next is the deletion at position 23. What do you guys think? My answer is decrease.
I think it will be increased
Why?
because it will be efficient due to the short space of ribosome binding site and start codon. I'm not quite sure. It's my opinion.
Does anyone have any other opinion?
Can I ask Akmal a thing?
Yep.
Okay, so do you mean that if the AUG becomes forward and then the RBS there is something in between the RBS and then so it will become increased like that?
It's like the line, mean like the between the space between ribosome binding site and start codon. It's like they shifted and then the distance becomes shorter, so it will be translate efficiently.
Oh, okay.
It's like that's what I'm not quite sure.
Yes, but I think that's true.
Like
I think that actually
Just
quite
like that. I'm not-
makes sense. But if let's say if we make forward the AUG, and then is it the next amino acid sequence will be changed or not?
I think no. I don't think so. It will change because it's like actually I'm not sure. Actually, I'm not sure. That's my opinion. Do you guys have any other answers? It's like
I'm not sure either. It will be either decrease or increase, but for sure it will change. It will not be. It will not be remain same.
I'm also quite confused with this question actually.
Could we just put like it change in the question, but don't specify it to decrease or increase?
Oh, so the answer will be changed.
Yes.
we follow majority.
Follow majority. So, Akmal, you increase.
I choose increase. What about you guys?
Okay.
I also.
Same increase.
Increase.
Go with increase.
Okay. Okay. Should we proceed to another question?
Okay.
All right.
Okay. Okay, predict the size of the pile enzyme under the following conditions. Which is the first is normal condition. What is the size? Does anyone know how to find the size?
My answer is I don't know. I don't know how to state the size, but I classify the size as small, medium, large. So
Okay.
So for A, my answer is medium because actually size of enzyme is around 50 to 70 kDa, the average size. So this pal enzyme is around 70 kDa. So I think the size of pal enzyme is between the range 50 to 70. So that's why my answer is medium. So what about you guys?
I wrote no changes because I don't know how to describe the size of the enzyme. So just put it no changes. What about you guys?
I wrote remain the same, but because I also don't know. I think medium makes sense.
Yes.
It will be medium.
Okay, medium. Medium is the answer. And then a deletion at position 8. My answer is medium. Because there is no change, right? At the
Yeah.
third question.
Yes.
I wrote no changes.
I
So it
I
will
I,
be
I did put slightly increase. Because I don't know why. I think there will be slight changes, but I don't know if it's increase or decrease. But I just put slightly increase because the RBS factor become a bit back forward, right? So I don't know. What about you guys?
I think I'll stick with my answer, which is it is medium.
Also for me,
Me too.
medium.
Medium.
So medium is the answer.
Next is a deletion at position 11.
I wrote medium.
Small. Is it small?
Smaller, right?
I wrote
Ah,
small.
yes, smaller than.
Smaller.
Yes, smaller for me. Does anyone want to have the difference answer? No?
Can I ask? It becomes smaller because the level in question 3 becomes smaller, become lower, right? That's why it become decreases. That's why the size
Size.
becomes smaller.
Yeah.
Yes.
Thank you.
Okay, let's move. Which is the insertion of U at position 32.
Smaller.
Oh, yes.
Smaller.
Is it due to frame shift mutation?
Yes.
Oh,
Yes.
okay.
And then is a deletion at position 31. Smaller? Is it smaller?
I wrote smaller.
Yes, smaller.
Same
And
reason.
F, a deletion at position 25 and an insertion of G at position 30.
Also smaller.
I wrote smaller.
Same.
I'm not sure because it alter amino acid. So I'm not sure whether it will be smaller or bigger. But but my answer is it will change size.
Either increase or decrease lah.
Yes.
Either smaller or bigger. So
So I'm not sure which one.
Okay. Move on.
bigger?
What? Is it F or G? No.
F.
F. Answer smaller.
Anyone wants to argue with this answer? No.
Okay.
Okay. And then G, the deletion at position 23.
23.
Is it decrease? Is it smaller? For G?
Smaller.
I think it will be smaller.
For me, I'm not sure.
Okay.
So
So you
Do
have
you want to argue?
hmm,
Just have any opinion about this?
No.
A deletion? No? Okay, we will continue, right? Okay,
No.
number
Wait.
5.
Just now,
Okay.
put the question number 3. For question number 3, the deletion at position 23. Do we put increase or decrease?
we put
Question
Increase.
increase
So I think the question 4G is increase. Is bigger
bigger. Okay.
Okay.
because it associate with each other.
Alright.
We will continue with the number 5, which is name the amino acid RNA that translate the following codons at position 23, 1007, and 1010. Okay, for 23, I have the answer which is F, MET, tRNA, MET. The small MET up there. Does anyone have the difference answer? F, MET.
Yes.
Can you repeat the answer?
F dash MET, tRNA, MET. The smaller MET up
Oh,
there.
okay.
I have same answer with
Same.
I know.
Same.
Okay. 1007. Anyone wants to try?
Me.
Okay.
The answer is methionine tRNA MET.
Okay, for 1010.
Wait, can I ask what is the difference between MET?
Yes.
What is the difference between MET, tRNA with threonine tRNA, the valine one? Because I put for the number 23 and 107, I put the THRE threonine tRNA val. What is the difference between that actually? Because in the slide
The
I
first
don't.
difference is for FMET, which is for 23. Okay. For 23, you're right. So it is the first start codon that meet the RBP here. So this is the first one. So the first start codon that it meets.
What about the amino acid? The amino acid. Yeah, I know that because it is the first codon that means, but it is like it is met tRNA. I understand that, but for the 107, I put TH tRNA val. There's no met in the front. Because in the slide I don't see any met in the slide. I think
I think I found it, but I don't remember which slide it is.
So for answer 23 and 107 it is the same lah. It is the same, right?
No,
No, actually
I don't
the
think.
23 should be formyl methionine, right?
Yes. F MET.
Because it can
tRNA for the first one, but the second the 107.
I wrote it as a methionine
Methionine.
tRNA.
Mhm.
Oh, yes.
Also the same.
Yeah.
Ah,
No, not same. Mean like the question for the at position 23, it should be formyl methionine. Formyl.
It is
And
also
the
known as
position,
F MET.
FMET.
I found it in the notes.
Okay. Okay, thank you.
okay, should we continue with the number 6? Okay, explain how does valine tRNA THR avoid the codon at position N and 10. 1010. Does anyone have the answer?
Can I try?
Okay.
So my answer is valine tRNA transferase has two adjacent catalytic sites. First, the synthesis site. Valine will attach to the tRNA. This site is hydrophobic, so valine is preferred over the THR. Meanwhile, the editing site is hydrolytic that removes wrongly bound amino acid. So this site is polar, so THR is preferred over valine.
Yes,
Yeah,
same
I will
answer.
like that.
2.
Yes. Okay, we will proceed with the number 7. How many ATP equivalent is required to translate this transcript?
I've got 1,320 ATP.
Can you repeat, Akmal?
I've got 1,320 ATP.
The same, 1,320.
I got 1,324.
I got 1319.
319.
Yes, same as Alia.
So,
Like, what kind of formula do you use?
yes.
I use 4n minus 1.
For this one? Where did you get that formula, by the way? Because
I asked our friends.
like I don't.
I found my answer on YouTube. No, the way
Yeah.
how to calculate it.
Yes.
But it's
I-
actually very long. I use like 1 page for it. Not like 1 page, like quarter of the page.
I also found the formula on YouTube. For
Same.
I think do you use the you count Akmal, can I ask, do you use the amino acid activation and then plus the initiation plus elongation plus termination?
Yeah.
Yeah, right. Then how do you get 1320? I mean I got
It's like
1324. Maybe they're the same, but
it's like first thing that I do is to find the number of amino acid in the sequence. So what I do is 1013 minus 20 minus. Can I take a look at the? I don't know what I wrote by the way. 13.
I think I got the same as you. Actually.
1013 minus 24. Yeah. 1013 minus 24 divided by 3. Because why divided by 3? Because it is in the form of triplet baseline to encode one amino acid.
So you got 300.
So I've got 3.6. So I just round up. So it will be 330 amino acids. So for the second step, I calculate the activation of amino acid. So one activation of amino acid required 2 ATP. So what I do is 330 times 2 equal to 660 ATP. So I got 660 ATP. So the step number 3 is initiation. So initiation we required 1 ATP. So that's it. And elongation 330 minus 1. Why do we need to minus 1? Because we already take it from initiation already used 1 ATP. So it will be 329 amino acid for elongation. So we times 2 because 1 elongation required 2 ATP. So 329 times 2 will be 6558 if I'm not mistaken. And finally termination is required 1 ATP. So we total up the number. So it will be 1,320. I'm not quite sure I'm doing it in the right way, but you guys can.
Can I add? I think okay. I use the same formula as you. I think I use the same times 2 and then plus 1 times 2. But for the transcript, I actually use 1015 minus 23. I think that's where we
1000.
1015 minus 23. Because at there you can see the UGA. UGA is actually the stop codon, right? So I use the UGA.
So
I mean,
it doesn't encode any amino acid, right? It just stop.
oh, so you
So my
at one.
yeah. So
one
basically, codon it just stop. It doesn't encode any amino acid, right? Am I right?
so you
Yes.
You're right, Akmal. Exactly the same.
I
so you use
think
13 minus 23.
24 minus 24.
Why does it
Because
minus?
24 means like 1013 minus 24. 24 is located at the AUG, so A, in front of the A.
I use 23 because you see the 21 U. The 21 is for U. And then 22 is for C, and then 23 is for A, right?
Yes. The 3 is for A.
That's why I use 23.
Okay, I wrong. yeah. 23 should be 23. I
But
think we should.
it's going to give you 330.
Still same, right?
Ah. I still got 100 if you count it back.
Yeah, I still get 330 amino acid.
Same.
Yes, it's still got 100, but you will get the no decimal one. Because just now you put you have decimals, right? And then you round it off.
Yeah.
So the answer is 1320, right? 1320 ATP.
Yes. 1320 ATP.
Yeah, 1320.
okay. Should we move to
Yes.
the next question? Okay, what is the size of this transcript?
I wrote 1015 nucleotide bases.
Yes.
Same.
1015. All right. Everybody this.
Okay.
So, do I need to recall all the answer?
Yes.
Yes. Okay. Good luck. So for number 1 is going to be MET, SASP, GLY, GLUE, SN, ASP, MET, VAL, and stop codon. For number 2, we all agree the process of the translation will occur efficiently. For number 3, it will remain unchanged due to the ribosome. Can you guys repeat why? Number 8.
Due to the RBS factor.
Yes. You the RBS factor the same. For B, decrease because there is no ribosome binding site. And C, decrease due to change of amino acid. D, also decrease due to change of amino acid. E, decrease due to change of amino acid. F, increase. Number 4, A, medium. B, medium. C, smaller. D, smaller due to frame shift mutation. E, smaller. F, smaller. And G, bigger. For number 5, the amino acid tRNAs for position 23, F MET, tRNA MET for 1007, methionine tRNA MET, and for 10,000, 1010, valine tRNA val. For number 6. For number 6, I didn't quite get what Alia answered. Can you repeat? your answer, number 6.
Okay, so number 6 is valine tRNA transferase has two adjacent catalytic sites. First, the synthesis site. Valine will attach to tRNA. This site is hydrophobic, so valine is preferred over THR. Meanwhile, the editing site is hydrolytic that removes wrongly bound amino acid. This site is polar, so THR is preferred over valine.
Okay, thank you. So number 7, 1320 ATP, and number 8 is 1015. That's all.
Okay.
Thank you.